Oh, wait, I've heard Harry's come back from his holiday soon.
Yeah, I heard he caught a flight at 3 a.m. this morning, I think.
I think he did, yeah, his tour of Africa. Oh, there he is!
Oh, Harry!
How you doing, Harry? Oh, how'd it go?
He's not looking that well.
Oh, he's not looking that well.
Yeah, he's a bit under the weather at the minute. He'd rather talk about his holiday later.
Okay. His shell looks different. Do snails get turns? Is that a turn?
You know, I'm not sure, but it does look quite different, doesn't it?
Very different, especially the sad face. It's around a balloon.
Well, we hope you get better.
Yeah.
Maybe share pictures with us later, yeah?
Alright.
Yeah.
Cool.
Right.
Okay. So we're on to chapter 5, e to the x stuff, which is quite exciting and quite new. So I'm going to start out what it is. So e to the x means, well, e to the x but to the power of, so it's an exponential.
Yes. Now, e is Euler's constant. It has a value of about 2.71, and it's irrational, and it will keep going on forever.
Yeah, original likewise.
So it's just like every other graph, though. That is an exponential.
Yeah, as anything to the power of 0 is 1, they always go through 1 when they hit the y-axis, and it goes up exponentially.
So it's very, very, very close at this side, but never actually touches 0, and escalates very quickly, like all the other exponentials.
Absolutely. And every graph, including exponentials, have an inverse. Well, every linear, one-to-one graph, sorry.
Mm-hmm.
But the e to the x one's got a special name.
Yes, and that's ln x, or ln x.
And that's French for...
Logarithm naturel.
Yeah, that's like the film, the full Monty, right, the show.
What are you on about?
You know, all naturel, it's all...
No, this is very, very, very
okay, well...
In fact, this comes from the idea, because this is to the power, you remember in core 2 we did logs. So if you have something to the e to the x, you can take the logs of that. But the logs of e, the log base e of a, is just ln x. And that's where the ln x comes from. It's the log of e.
Mm-hmm.
And as Drew said, it's the inverse, so I'll go ahead and draw it in blue.
Absolutely. Remember with your inverses with your one-to-one graphs, you just reflect it in the y equals x line. It's just the other way around.
I'll draw in the...
Yeah, drawing the y to the x, and it just goes through the origin and sort of 45 degrees on each side. Also,
just reflect it like that.
Just like that. Now, there's a few things to know about e to the x graphs, but I think we should get those written up first.
Yeah, we'll get a few practice questions, because being to the power you can use your logs and stuff, but it's ln, so it's very different.
It's different, but similar rules. We'll get onto that.
Get right onto that.
Oh, let's crack on. We're back.
We are back. We briefly mentioned the ln x thing.
And where it came from. We're going to reiterate it and explain it a bit further.
Yeah, so we need to take a trip back.
Alright. Many years ago, there was a guy called Euler. That's too far, isn't
A
it?
bit too far. I'm thinking more last year, core 2.
Yeah. Like, a little bit off, a little bit French as well, you know, Euler. But remember in core 2, we had the y to the a to the x relationship between, and how to change that to a log. Where if you had a log, it would be x equals log to the base a equals y. Well, of y, sorry.
So that is the same as that. You could go from one to the other.
So we did the same thing with y equals z to the x. We get something rather swish.
So y equals e to the x. If we apply this rule, it's going to be...
So I have x equals log base c of y. But log base c, that's something special, isn't it?
Is indeed log base e we express as ln
We do that.
of x, where x would be your y, which would just be a value. I'm just expressing it algebraically with the y here.
Mm-hmm.
And you can use this relationship, which we use in our rules we're going to be using in a few seconds.
We do. And because of this, we can convert e to the x to ln of x. Often, it's very, very handy, isn't it? There's a symbol. I'm not sure quite how to say it, but it's a bit like the show each other sign, isn't it?
I got it. It means it is well equal to bruv, and don't even say anything other than that ting and stuff. Is what it means.
It's well equal to yeah. I'm pretty sure that's exactly what it is. It's in the textbook, right?
Yeah, textbook definition, right?
Yeah. It's in French, but don't worry about that.
E to the x is well equal bruv to ln x.
Yeah. Because Wayne's Street, he's
on Wall Street.
Yeah, so street. You live on a street.
Yeah, just there actually.
Yeah, that was nice.
Yes, lovely.
That's a fence. Yeah. Alright, anyway, and then there's some rules. So the rules for ln of x are the same as the rules for log of x, but we'll remind you because there's a revision video. So, if we had ln of a plus ln of b, what do you think would be, Wayne?
Well, based on our log rules from core 2, it's going to be ln A times b.
Oh, he's got it. So, what else we?
Well, if we have ln A minus ln b, let's see if you can riddle that one. What's that going to be?
I think it's going to be ln A over B, Wayne.
Oh, I think you're probably right.
Nailed it.
And finally, ln A to the power of b.
Ah, you can move the power of B to the front, so we be lots of ln A.
Excellent.
And
what we could do with here is a place to use these rules.
I think you're right, Wayne. How would it be?
If I look behind me.
Well, below me.
Oh, there you go.
There you are. That's an example. Don't know how that got there, but there it is. And we're going to do it. So what you need to do in the exam, it'll say, write this as
a single logarithmic expression,
just like that, but with words on paper. And we're going to show you how to do that right now.
Okay, so first, this is 4 ln of a lot. This is 1 ln of a lot. So we want to get rid of the 4.
Yeah. So to get rid of the 4, we use our last rule, but the other way around.
Yeah. So we're going to be using this one, where because the 4's in front, it's the coefficient of the ln. You can use it to make to the power of the a, where a is everything inside the bracket. So Triv's done that very neatly there.
Absolutely. And now we have ln take away a ln, which is what we want. We use our take away rule.
Yep, which is this one here. So we're going to have ln x plus 1 to the 4 over x. And that's going to be our final answer.
It is, because that would count as a single logarithmic expression. You could expand it and then do the x thing, but you don't need to.
No, because that's just it.
Absolutely, and now I've gone through that, I think it's time for a test yourself question.
First, it's time for a cup of tea. Is that a break?
Oh, yeah, cup of tea. Love tea. Question time.
Test yourself, page 87, question 7 from this book.
Which is pink. I haven't seen it for a while, Wayne.
No, I haven't. I've been focusing on the other two.
Yeah, because we're doing mechanics and core 4. They'll be up at some point as well.
Yes.
Anyway, on with the show.
Yeah, it's quite a big question.
It's
and
quite
typical of what you get in the exams.
So here we are. It says the diagram shows the graph of y equals f of x, where f is defined for all real numbers by f of x equals 2e to the minus x.
Okay, what I'm going to do is I'm just going to draw this up.
And there's a little diagram that you can't see, so we're going to draw it much bigger.
Looks a bit like that.
It does look a bit like that.
And this is y equal, or f of x equals...
Yeah, f of x, they're the same thing.
X, like that.
Just like that. So that's all there. So part A is describe the sequence of geometrical transformations by which the above graph can be obtained from the graph of y equals e to the x. That was quite a mouthful, Wayne.
It was, but I understood. This is a translated graph of y equals, or f of x equals e to the x.
It is.
How has it been done, is the question.
Now, I think in some of our early videos, we mentioned that sometimes it matters what order you do transformations. In this case, it doesn't.
It doesn't. This time it's just a reflection and a stretch. If you stretch it then reflect it, it will look the same.
It will.
But good to keep your eye out on that stuff anyway.
Yeah, but as Wayne says, that's the answer. We'll say it a bit slower, just in case. So, we want it to become e to the x. So we want to get rid of this 2. So to get rid of that 2, well, to get to that 2, we had to stretch it by 2.
Yep, because it's in front of the e to the x rather than in front of the x. You know it's stretched in the y direction.
Absolutely.
So I'll put that up. Stretch. For all your marks you'd want stretch. Scale factor, I'm going to be lazy and do that. In your actual exam, put scale factor.
And then 2 in the y direction. Those are the marking point. Often this is quite mark heavy because of all the points you have to make.
Yep.
Then the other one is it's a reflection in the y-axis.
Yes. Reflection in the y-axis.
Cool.
You see the minus is in front of the x. You know when anything's to do with the x, it's broken and not what you think. So there you go.
So there you are. It's just things you have to remember. That's why I hesitated, because it does feel wrong, but it's not. Thumbs up. So part B, it says copy the above diagram, which Wayne has already done very nicely, and then it says sketch on the same axes the graph of y equals f to the minus 1 of x, so it's the inverse of the original graph.
You were mentioning earlier how to do an inverse with the y equals x line.
I was. It's a good practice is to draw on the line, and then use your hand as a mirror, I think is a good way of doing it.
Okay, yeah.
So maybe we could do it in a different colour.
That's a good idea.
I've got purple, which is personal next time.
Wow.
And it's very exciting.
I don't have a purple in my bic, it's just Edding.
It's very
That's
special.
me.
German engineering.
For your hair.
or pens. Caffeine shampoo is weird, isn't it? Why caffeine shampoo?
I don't know. So that should be a neat curve, but you can see both of the things are going to be inside the other one if you were to put your hand to it yourself and have a look.
Yeah.
I don't know where the lid's gone.
Oh, I threw it, so that's that. Oh, it's here. Here we are. There's a lid.
Otherwise it'll dry up.
That'd be very upsetting. So now we have part C. This was A and B. Part C is find an expression for f to the minus 1 of x. So
we're finding the inverse of this.
yeah,
And to find an inverse, what you sort of do is you've got this 2.
you sort of swap the x and y and try and get it to get y equals,
So
basically.
the second it's y equals that, the inverse you're going to swap that y with
Make
that
it x equals, and then rearrange to make y the subject.
That's exactly how you do it. So first step, divide both sides by 2.
Yeah, so you get x over 2 equals e to the minus y. Then you want to get rid of the e bit, and to do that we take ln of both sides.
Yeah, so it's going to end up ln of, I'm going to express it as a half x, you can express it as x over 2.
They're the same thing.
The ln will get rid of the e,
So equal minus y. You don't want minus y, you just want y, so you minus the other side, so it becomes minus ln of half x. And that's your answer. But the question doesn't finish there because it's massive.
Yep.
Then we have part D, which is state the domain and range of f to the minus 1.
Right.
So a good way to think about when you do the inverse, of the original it's the opposite of the original. The range is the domain of the inverse and the domain is the range of the inverse.
Yep.
So if you look at our original graph,
Got this one here. The domain is to do with the x values.
it is.
And in this case the domain is going to be all real numbers.
Yeah, but a special way to write that.
Ranges infinitely and infinitely.
It does do that.
So it's expressed x, little e thing like that, with a double line r like that. It's not the best drawing I've ever done, but it's like that.
Bit like that, yeah.
But for the inverse, it's going to be the range is going to be
For
what
this
was
one.
the domain. You could also have looked at this graph. It's also going to go on infinitely in both directions.
Yeah.
So you could have looked at it directly.
But personally I find it easy to do it and then just swap it, but
Yeah,
you can do it from
might
either
have
side.
drawn this one wrong as well. That's what you've got to think about. That one's definitely drawn right because it was given to you.
yeah, so that's a good way to try and limit any mistakes you do make. So then the range of our original thing is that to do with the y things. And because it's an exponential, it doesn't touch 0, it must be greater than 0.
Yeah, because it hasn't been shifted up or down when it was translated, just
Mhm.
sideways and stretched. So greater than 0 is now going to be the domain of this one.
Yep.
And you've got to say
F
f
of
to
x.
the minus 1 of x
Yes.
is greater than 0. If you were to put y or anything like that, you nearly always don't get the mark. It has
Yeah,
to be.
they're quite mean, so they like this notation. We're still not finished.
Oh,
I know. This is even larger part of the question. This is part E, and it says a time t hours after an injection, a hospital patient has F not to T milligrams per litre of a certain drug in his blood. Find the time after the injection at which the patient has 0.5 milligrams per litre of drug in his blood. Whew.
Okay, so the volume in his blood is actually the y here, the f of x.
Yeah, and you want to
And
find the T.
is x.
Yeah.
So we've got y equals 2e to the minus t instead of x, but we
Yeah.
know y was 2.5 or 25?
It was 0.5.
0.5, I just wasn't listening. 0.5 equals 2e to the minus t, and we've got to find t.
Yeah. So like we did to get to the other side, we're just going to keep moving them.
Yeah, we're going to rearrange to find t and then plonk the numbers in.
We are.
So 0.5 over 2, I'm going to express it as a fraction now, is
Yeah.
a quarter
It is a quarter.
equals e to the minus t. You take logs of both sides.
Yes, you have ln of a quarter equals minus t, then you do the minus thing. You could have gone straight to here, but it's also a possibility that you could have done it wrong, and it's worth doing it twice to check your answers if they're the same. Nailed it.
Could you do that on a calculator?
Yes, if they want the actual value, so here we go. Minus.
You should end up with a positive value of t because time might be negative unless you run really bloody quick. But that's not maths, that's physics.
Yeah. Oh. Sorry. Only one hand does make this slightly more awkward. And it is 1.39 or 1.4 will do, I think.
1.4 and it's hours, I believe.
It is. Yeah.
So whatever you just injected with, I've got 1.4 hours left. What was it, by the way?
Oh, I think it was ketamine.
Ah, well, in 1.4 hours,
You'll be quite sleepy.
yeah,
Yeah. So, tea?
it takes effect quicker.
That's because Wayne isn't a horse. So, until next time.